Yeah, thank you. Fine. Okay. So if you observe yesterday, actually one of your friend has asked it out. Okay. So if you see the program, the last program which we discussed yesterday. Okay. So what was that program? That program is nothing but okay. So yes, can anyone tell me what is the last program which we discussed yesterday? Yes, at least the name of the program or whatever you remember. What is the last program we discussed yesterday? Any guess? Okay. Uh, yes, exactly. Thief stealing maximum amount. Yes, Rija. Okay. So that was the question. Actually, we discussed yesterday. Yes, that was the last question. So if you observe, I've actually written the code. Okay. So yeah, 1 minute. I'm sharing the screen. Yeah. So if you observe, if I take inputs, 1 minute. Okay. Uh, yes. Okay. So let it be. We'll discuss. So if I take inputs 10, comma 5, comma 1, comma 7. Okay, four houses. What should be the maximum amount a person can steal? Okay. And actually, there are some conditions. What are those conditions? Okay. That person cannot steal from adjacent houses. Okay. So if he can, if you want, he can steal. If he's stealing at first house, he cannot steal at the second house. Okay, and he can steal at the third house. Yes. So if he's stealing at the second house, he cannot steal at first and third house. Yes. He cannot steal in adjacent houses. Okay. So if I take this program, okay. So this actually we discussed yesterday, but yeah. So we made a small mistake. Okay. So if I take this program, okay. So this is what the code which we discussed yesterday. What was the code? Okay. 1 minute. Uh, yes. Okay. 1 minute. Yeah. So if you observe, what was the code we discussed yesterday? If there is only one value, if there are zero houses, return zero. If there is only one house, yes. So if there is only one house, just return 10. Okay. So if there are two houses, maximum of 10 and 5. That's what return maximum 10 and 5. Okay. So if there are three houses, then what we took yesterday? So we took this as first one as V1. So V1 is equal to H of value. Okay. So and V2 is equal to H of value of 1. Yes, that is what we did. After then what we did. So now, for example, okay. So if I take this as the ith house, so my question is I should consider or not. Okay. So for that reason, what I did maximum of if this is I, this becomes I minus 1, this becomes I minus 2. So if I'm taking I minus 1, I should not take I. So if I'm taking I minus 2, I can take I. Yes. So for that reason, what I did maximum. Okay. So up to I minus 1 or okay. So up to I minus 2 plus a of I. If I'm considering I minus 1, I should not take I. If I'm not taking I minus 2, then I should take I. That's why I wrote. If I'm taking I minus 2, then I can take a of I. Okay. So this is what the thing we discussed. So that is what I wrote here also. Okay. So maximum. Uh, okay. So if I'm considering I, then V1. V1 is what? V1 will store up to I minus 1, and V2 will store up to I minus 2. Yes. Okay. So this value will be V2 and this value will be V1. So I should select the value from either V1 and I or V2 of I. So for when I is equal to 3, it will work. Yes. So 10 plus 1. So I should select a maximum value of 10 plus 1 or I should select a 5. Yes. So here my value will be 11. Yes. So for example, if I take my fourth value, yes. So if I take my I value as 4, so for example, what are the values? 10, 5, 1, and 7. What should be my output actually? My output should be 17. Yes, my output should be 17. But what is happening here? Okay. So but what is happening here? So if you observe, 1 minute. So if you observe, I'm executing. I'm executing this program. Okay. So if I'm running this program, I hope you can see the screen here. Okay. So it is giving me 12. Whatever the program we discussed yesterday. Okay. So what it is giving? So it is giving us 12. So what is happening here? Actually, it is not considering the entire question. Okay. So it is taking these two values and these two values. Yes. So if I take this as I, okay. So if I take this as I, 1 minute. Okay. So if I take this as I, so this will be I minus 1 and this will be I minus 2. Yes. So it is considering I minus 1 up to I minus 1 maximum value is 11. Yes. Okay. So I minus 1. So that is nothing but V2, comma. Okay. So I minus 2. I minus 2 plus I. So that is V1 plus 7. So it will be 11 comma 12 and it is giving us 12. But our output should be 7. Yes. So then tell me what should we do? Yes. Okay. So what was the logic we discussed yesterday? Whenever I am finding for I value, there are two conditions. What are those conditions? Okay. So maximum up to, okay. So 1 minute. Yeah. Maximum up to I minus 1 or, okay. So, or what are the things I should consider? Okay. So maximum up to I minus 1 or maximum up to I minus 2 plus that whatever may be a of I value. Yes, if you are taking I minus 2, then consider I also. If you are taking I minus 1, then don't consider I. Yes, so for this, I should find out maximum. So in these two things, whatever is greater, I should get that value. Okay, so if you observe here, if I am making V1 is equal to H of 0, okay. And if I'm making V1 is equal to A of 0, let us consider A of 0, V2 as A of 1. Okay. So then what happens? Then V1 will be 10, V2 will be 5. Yes. Okay. So for the next iteration, what happens? Okay. So for the next iteration, V1 will be 5 and V2 will be 11. This is when I is equal to 3. Okay. So if you observe, this should contain maximum up to I minus 1. Yes. So always I should contain maximum up to I minus 1 and maximum up to I minus 2. So if I is here, what is maximum up to I minus 1? Yes. What is maximum up to I minus 1? So maximum up to I minus 1 will be 11. Yes. So I minus 2 is here. What is maximum up to I minus 1? Maximum up to I minus 1 should be 10. Yes. So you should take maximum up to I minus 1 or maximum up to I minus 2 plus A of I. So I minus 1 maximum up to I minus 1 we got, that is 11. But what is maximum up to I minus 2? What is maximum up to I minus 2? I am directly considering V of 1. Actually, I should not consider first value. I should consider maximum up to that value. Yes. Okay. So that is what the mistake we did yesterday. So for that purpose, I am changing it now. Okay. So if you observe, let me show you. Okay. So instead of taking directly V of 1 value, what I'm doing, so I'm directly taking maximum of so always maximum up to I minus 1 or maximum up to I minus 2 plus A of I. Yes. So maximum up to I minus 2 will be 10 and 5, maximum should be 10. Yes. So if I execute for 1, 5, 10, 5, 1, 7. Okay. So I'm getting an output called 17. Yes. I hope you can understand. Yes. So if I have any doubts in this, please ask. So in 10, 5, 1, and 7, my output should be 17 because I'll stole from first house and I'll steal from the last house. Yes. So 10 plus 7, it is 17. Okay. So this is about the question from previous day. Yes. So the logic which we discussed is this: maximum up to I minus 1 or maximum up to I minus 2 plus A of I. So if I go for maximum up to I minus 2, it should be maximum of up to 2 values. Okay, so it should be maximum of, always it should be maximum of uh, h of value of 0 or h of value of 1. Yes. Okay. So now let us see another question today. 1 minute. Let me erase all these things. Yeah, fine. This was about yesterday's question. Okay. So still, if you have any doubt, please ask. Okay, 1 minute. This is done yesterday. So yes, 1 minute. Yeah, I hope you can see the screen. Try the first question. Try this question. Okay, so clearly understand, clearly read the question. Only question looks big. Actually, problem is very easy. Okay, so only the question looks big. Yes. Read the question and try to understand. Okay. The parcel section of the head post office is a mess. Okay. The parcel that need to be loaded to the vans have been lined up in a row in an arbitrary order of weights. Okay. So the head postmaster. Okay. So the head postmaster wants them to be sorted in an increasing order. Okay. Increasing order of the weights of the parcels with one exception. Okay. So what is that exception? He wants the heaviest and presumably the most valuable parcel kept nearest his office. Okay. So nearest his office. Yes. So you and your friend try to sort these boxes and decide to sort them decide to sort them by interchanging two boxes at a time. Such an interchange needs effort. Okay. So effort equal to the product of the weights of the two boxes. The objective is to reposition the boxes as required with minimum effort. Okay. So input format, they gave input format and then they gave some inputs and then they gave some outputs. Okay. So please go through this thing. Okay. So please try to understand. So that is what the question given. Okay. So please try to understand. And if you have any doubts, please ask. Please read the question properly and try to solve. Actually, there is nothing to explain in this question. Okay. So the question is very easy. You can just solve by yourself. Yes. Okay. So yeah, can anyone tell me what is arbitrary order? Arbitrary order of the weights. Can anyone tell me what is the meaning of arbitrary? Yes. What is the meaning of arbitrary? Yes. Any answers? Okay. So yes. What is arbitrary? Arbitrary is nothing but random order. Yes. Arbitrary is not like in a particular increasing or decreasing order. It will be in a random order. Okay. So fine. Let me take the inputs first. So I'm taking some inputs. Uh, yeah. Okay. What are the inputs given? My inputs are 1 minute. Okay. So yeah, let me read input format. The first line consists of two space separated positive integers, giving the number of boxes. Okay. So that is nothing but n. N is number of boxes. So n is equal to 5. Uh, Next, and the position the head post and the position of the head postmaster's office. Okay. So P is equal to, let me take P's position, that is 2. So at second position there is an post office. Okay. So now next, the second line consists of n space separate positive integers, giving the weights of the boxes. Okay. So these are all the weights of these boxes. So what are those? So let me take that in an array. So 20, 50, 30, 80, and 70. Yes, 20, 50, 30, 80, and 70. Okay. So and then output format. What is the output format? The output is one line giving the total efforts taken to get the boxes in the sorted order. Okay. So on the heaviest is in position K. Yes, and the heaviest should be in position K. So now tell me, what should I do? Yes. What is the logic which we can apply? Any ideas? Yes. Any ideas to apply? Any logics here? So for example, okay, so let us see the first option. Okay, first input. What is the first input? First input is 20, 50, 30, 80, and 70. And at second position, okay, so at second position, we have a post office. So I need a maximum value at the second position. Yes. Okay. So normally if I do, so normally what will we do? So normally, so whenever I want to swap, okay, so I want to get maximum at the post office, right? So maximum box, the box which is having maximum weight. So these are all the weights. The box which is having maximum weight should be at the post office. Okay, and the post office is at second position. That means I want 80 should be here. Yes, I want my 80 to be here. Okay, so after then what? Okay, so if I want my 80 here, then 50 goes to that position. So if you observe, after arranging, my position should be 20, 80, 30, 50, and then 70. Yes, 20, 80, 30, 50, and 70. And they gave one condition. So what is the condition? Whenever you are swapping, and what is my output? My output should be minimum effort. The output is in one line, giving the total efforts taken to get the boxes in sorted order, and the heaviest in position K. Okay, so on the heaviest in position K. So what can we do? Tell me. So normally, so if you tell me, sir, first I'll sort all the boxes and then I'll shift this. So if you try to do that thing. So first, if you try to sort all the boxes, okay. So whenever I want to sort, okay. So what should I should multiply? So my effort will increase a lot. Yes, and so if you observe what is effort, so here such an interchange. Okay, so such an interchange needs effort equal to the product of the weights of the two boxes, and the objective is to reposition the boxes as required with the minimum effort. Yes, so if you observe, if I try to arrange everything, okay, so actually these are already in sorted order. Okay, so for example, if I get some boxes like 70, 20, 60, okay, so 50 and 40. Okay, so first if I try to sort, so if after sorting it becomes 20, 40, 50, 60, 70. Yes, so for this, if I need to sort, so if you apply bubble sort technique, so for 7 will be compared with this, so these two will be shifted. If these two are shifted, I'll multiply. So 7 into 1400 will be my effort. Next, yeah, next you'll compare 70 with 60. Okay, so 4800 will be my effort. Next, 7 with 5, 3500 will be my effort. 70 with 4, so 2800. So if you try to first sort, so this is only to get 7 at the last position. Next, for 6, So here, so first, if you try to sort, your effort will be more. But what is my main objective? My main objective is what? My main objective to be minimum. My effort should be minimum. Yes. So here, so first we'll come to this part later if the elements are not sorted. So for example, here if the elements are already sorted almost. So 20, 50, 30, 80 and 70. Okay. So 20, 50, 30, 80 and 70. Okay. So normally, so here actually we can do two things. Okay. So 1 minute. So I'm erasing this thing. So yeah. So if elements are not sorted, we'll come to that part. Okay. So that is also simple. Is if the first, okay, what are the process we are doing? Do it now. Okay. So now, so generally, so if I try to swap, so if I, so yeah, I want at second position that should be shifted with the maximum number. So if you observe, if I try to swap, what is my effort? My effort will be 4,000. Yes. If I try to swap these things, so my number becomes what? 20, 80, 30, 50, 70. Yes. So if I try to do this thing, so all these elements are in sorted order and they give one exception. What is that exception? At the post office, you should have maximum number. So if you observe, all the conditions are satisfied. Okay. So for this thing, if I just swap 80 and 50, because maximum should be at second position. So for that I'm swapping. So whenever you're swapping, what should be the effort? Effort will be number of boxes. Okay. So effort will be what? Weights multiplied. So here my weight is 80, here my weight is 40. So I'm multiplying those weights, so it will be 4,000. Okay. So this is one process. So can we minimize the weight? Yes. So can we minimize the effort? Yes. So can we implement any other logic here? So here, if I observe, I'm getting my effort as 4,000, but they are giving our what should be the effort? Effort as 3,600 only. So we can reduce the effort. So can anyone tell me how can we reduce the effort for this test case? Yes. Any answers? Anyone? So here, if I go with the logic, whatever that is telling, okay. So I'm just swapping maximum with that position. So at position I have 50, maximum is 80. Okay. So and if I try to do that, what is happening? My effort is becoming 4,000, but they're telling minimum effort can be 3,600 only. So can anyone tell me how can we minimize the effort? If you want, you can speak or you can send it in a chat box. Yes, any answers? Okay. So did you understand the question first? Everyone. Okay. So respond if you have understood the question or not. Uh, yes. If you have understood the question, please respond. Yeah, thank you. Uh, yeah. So if you observe normally, we are getting, yes, yes. Okay, fine. Thank you. Thank you very much. If you are getting our responses 4,000, but they are telling our response can be made 3,600 only. Okay. So yes. So can anyone tell me how can we reduce our effort? Okay. So if you observe here, we are doing only one operation. What is that operation? Multiplication operation. And my value should be minimum. Okay. So then what we should do? Generally, so if I want to minimize this value, I should multiply this maximum with a minimum value. Yes, right. So if you want to get a minimum value, so this 80 I cannot shift. Okay. So this 80 I cannot change. So definitely 80 should be multiplied with some value. Okay. So this value cannot be changed. So this 80 should be multiplied with some other value. Okay. So where I can get my value, where I can get effort as minimum. Yes. Okay. So one of your friend is telling take maximum element, leave kth position element and shift other elements by one. Okay. So and one more thing. So if I try to shift all these elements, okay. So one of your friend is telling so shift all these elements. So if I try to shift 8 3 is 24. Okay. So and then 8 5 is 40. So again my effort will be increased. Yes. Okay. So yeah. So what can we do? Yes. Okay. So my value is 80. Okay. So for that reason, what yes teacher, that is what I was expecting actually. Okay. So instead of doing this process, so directly shifting with K position. Okay. So what can we do? Okay. So now clearly observe. Okay. So first, if I want to get a minimum value, so this is the position, right? Okay. So this is the position, and this is the maximum element. So this is position, this is max. Okay. So if you observe, so if I want a minimum value at this number, I want a minimum. Yes. So here I have 50. So for example, here I had a minimum value, then there is a chance of getting my effort as minimum value. Yes. So I'll be multiplying this maximum element with position value. So here in this position I have 50. In this position, if I can get a minimum value. So if you observe in this thing, what is the minimum value? My minimum value is 20. Yes. So now what I'm doing? So now actually I'm swapping these two. Okay. So it will become 50, 20. Okay. So 50, 20, 30, 80 and 70. Okay. So if you observe, this is max and this is position. First thing. So if I am swapping here, okay. So for the first time, okay. So what I am doing, so I am interchanging K and minimum. So K and minimum are getting interchanged. So or sorry, position. Let me take. I have taken variable as position, right? So I'll take my variable as P. Okay. So I'm taking P. So position and minimum. This is minimum. Okay. So position and minimum are getting interchanged. So for this thing, what will be my effort here? Here my effort will be 50 into 20. So which is nothing but 1000. Yes. After that, okay. So after that, what will I do? So now here I have a minimum value. Yes. So now I can interchange this maximum and then P. So second step, what I'll be doing? So I'll be interchanging this max with this position. In this position, I got a minimum value. Yes. Okay. So max and position are interchanged. Okay. So here, what is maximum? 80, and at the position I have 20, so it becomes 1600. Yes. So my array becomes 50, 80, 30, 20, and 70. Yes. Okay. So next what? Next it should be in sorted order, right? So now what I'm doing? So now again I'm interchanging. So now at kth position I have so at this position. Okay. So at the position I got maximum number, but this should be in sorted order, right? Okay. So if I want that to be in sorted order, then what should happen? Okay. So then again this 20 and then this position. So this maximum and minimum should be interchanged. Yes. So every time here there was minimum, here there was position, here there was max. So here there was minimum, here there was position, here there was max. Okay. So now after this, what should I do? Now I should interchange both. So now again I am interchanging minimum and this maximum value. Okay. So that is how much? 20 with 50. So 50 and 20 are interchanged. Now those two again should be interchanged. So 50 into 20, again it becomes 1000. Okay. So if I interchange that, so my position will become 20, 80, 30, 50, and then 70. Yes. Okay. So now tell me, what is the total effort I took here? 1000, 3000 plus 600. So totally my effort is 3600. Yes. Okay. So yeah, actually this is what our program is. Okay. So how many operations I'm doing? So first, whatever may be the position they are asking. Okay. So whatever may be the position they are asking, at that particular position, I'm getting minimum value. Okay. So after then, uh, change maximum and then this at that particular position, I'll be having a minimum value, right? So maximum and then minimum will be interchanged. So and again reverse that operation, whatever you did. So minimum and then max. Yes. So at the end, this will be my array. Okay. So here what I am doing. So yeah. So if you observe here, all the conditions satisfied. My output is in sorted order except at the position given. That exception is already given in the question. Yes. The output is one line given. The total effort taken to the boxes in sorted order and the heaviest in position K. So if you observe, all the elements are in sorted order and the heaviest is in position K. Yes. Okay. So if you observe for the second test case. Okay. So now we'll see the second test case. Okay. So yeah. So what is the second test case? Our second test case was same 5 and then 3. So this is n value. This is position value. Okay. And what are those elements? Elements are 20, 50, 30, 80, and 70. Yes. 20, 50, 30, 80, and 70. Okay. So can anyone tell me what will be the, okay. So yes. Okay. So can anyone tell me what what should be our effort now? I know you have already seen the answer. Okay. So try to get the effort now. What will be the effort? Okay. So what is the process you'll be doing so that we'll get minimum effort? Okay. So generally if I do, so my at third position, I should get maximum value. Yes. So normal process if I do, so my effort will be 80, 30, and then this 70. Yes. So if I am interchanging these both, so my effort will be 2400. Yes. Okay. And then what? Next what? So are those in sorted order? No, they are not in sorted order. If those need to be in sorted order, these two should be exchanged. So 50 and 30 should be exchanged. Okay. So if I do that, so if I exchange those 20, 30, 80, 50, and 70. Okay. So 5 and 3, I'll get my effort as 1500. 5 3 is 15. So my effort will be 3900. Yes. So here I'll be getting my effort as 3900. But what should be the effort now? Okay. So what should be the effort? Effort should be 2800. So can anyone tell me how will we get this effort? Yes. Okay. So now can anyone tell me how will we get that particular effect? Uh, yes. Okay. We'll see it now. So what are the process we are discussing? So first change it with the minimum value. Okay. Exactly. Okay. So first change it with the minimum value and then try to do it. So first we'll try direct method. Okay. So here actually I can tell if I try to I can tell this is a direct method. So directly change maximum value with the position number and then check. Okay. So actually here we should do two process. What are those? So what if the direct, okay, fine. We'll discuss. So this is one way. So but here I am getting my output as 3900. Okay. So but so we'll see how will we get our effort as 2800. Okay. So I'm taking my effort. So my values are 20, 50, 30, 80, and P. So now I'm writing the numbers. Okay. So 1 minute. This is P. This is max. And this is minimum. Okay. So this is P. This is max, and this is minimum. Okay. So first. Okay. So first, what should I should interchange? I should interchange the values, right? Okay. So I'm interchanging. So here there should be I'll be interchanging with position minimum value. So here 20, here 30 will come. Here 20 will come. The remaining all are same. So 50, 80, and then 70. So what is my effort? My effort is 600. I'm interchanging these two. Okay. Next. Next, what should I do? Maximum should be interchanged with minimum. So all this will be same. So 30, 50, 70, and these two should be interchanged. Okay. If I interchange that 80 and 20. First step. This is first step. Minimum should come to the position. Next, second step, maximum should be interchanged with position. Yes. So it will be 1600. Yes. Okay. Next what? Okay. So next, are these in sorted order? No. So and again, these replace this element with this element. Okay. So yeah. So next what? Next here 20 should be there. Here 30 should be there, and all the values should be same. So 50, 80, 70. Yes. So what will be my effort? My effort again will be 600. So totally how much? 3 6 are 18 plus 1000, 2800. So that is how effort is 2800. Yes. So that is how effort is 2800. Okay. So this is the logic. Uh, this is the logic for this program. Okay. So if you did not understand, please. Okay. So please ask me. Okay. So I'll just tell the logic for this. So the main part is this one, right? Okay. So what is that part? So changing position with minimum. Okay. And then position with maximum element, and then maximum with this element. So I'll write down the logic for this. So after this is done, next is sorting only. Yes. So if you observe here, so until here, if this is done, next is sorting only. Yes. So you need not to worry about that. Okay. So for that reason, okay. 1 minute. Yeah. Okay. So now we'll see the code for this. Okay. So 1 minute. Will yeah. So I understood. I understood the doubt. Okay. So now we'll see. We'll read the question properly. Increasing order of weights. The head postmaster wants them to be sorted in an increasing order of the weights of the parcel, with one exception. He wants the heaviest and presumably the most valuable parcel kept nearest his office. Okay, so you and your friend try to sort these boxes and decide to sort them by interchanging two boxes at a time. Okay, so such an interchange needs effort equal to the product of the weights of the two boxes. Okay, so the object is to reposition the boxes as required with minimum effort. Okay, so the first line consists of two space separated positive integers giving the n number of boxes and the position of the head postmaster's office where k where the heaviest box must be. The second line consists of n space separated positive integers. Okay, so giving the weights of the boxes. So you may assume that no two weights are equal. Okay, so you may assume that no two weights are equal. Okay, fine. So output format, output is one line given the total effort taken to get the boxes in the sorted order and the heaviest in position K. Okay, so yes. Okay, so we'll see the second test case again. 20, 30, sorry, 20, 50, 30, 80, and then 70. So 20, 50, 30, 80, and 70. Okay. So these are elements 20, 50, 30, 80, and 70. So my position is 3. Okay. So position is 3, position 1, position 2, position 3. Okay, so first obviously, so if I'm going, I am getting 2 3 24. Okay, so if I try this logic, 20 50, so instead of going with this, okay, so I'm directly changing 80 30 70. Okay, so what I'm getting, so I'll get my logic is effort is to 2400. Okay, so next these elements are not in sorted order, so if I try to arrange, so it becomes 20 30 80 50 70. So here it is 1500. So my effort will be 3900. Okay, so obviously this is not the logic. So what is the one more way? One more way is swapping it with smaller number. Yes, so let us check swapping it with smaller number. Yeah, so if I swap, so first time, so at position is 3, right? Okay, so my numbers will become 30 50 20 80 and then 70. Yes, so if you observe, I have swapped these two. Okay, so what will my effort? My effort will be 600. Okay, so after that, if I yeah, so after that, if I try to write on the next swapping is with this 30 50 80 20 70. Okay, so next my effort will be 1600. Okay, so next what I can do next, we were actually sorting 30 and 20. Yes, so if I sort 30 and 20, is it required actually? So if not, if I go with so up to now I got 1600, sorry, 2600. Next, only 200 effort. Okay, so nowhere you will get effort as 200. Okay, so I think there is some problem with the logic question. Okay, so I need to check the question. Okay, I need to check the question. 20 20 50 30 70 is not in sorted order. Yeah, so Vinaya is telling sum is 2200. Sorry. Yeah, sorry, it is 2600. I should get my effort as 600. So effort 600 will get here, but if I try to do that, 20 here, 50 here, 80 here, 30 here and 70 here. Okay, so I'm getting 600. It's fine, I'm getting 2800 as a sorted order, but my elements, but my numbers are not in sorted order, right? And again I should shift these two definitely, because if in the question they are giving as a sorted order, okay, so definitely I should change this. Okay, so okay, fine. I'll check the question. So I have copied actually this question from other side. So I'll check the question. Then we'll discuss. Okay. I need to check the question whether your output is correct or not. Okay. So where is 2800 or is it greater? Okay. So I'll check that. Okay. So after then we'll see. So for now, actually, this is the process. So if I want to get a minimum effort, okay. So minimum and position will be swapped. Okay. So after then, position and max will be swapped. Okay. So after then, minimum and max will be swapped. So these are three steps. Okay. So we'll see whether here second test case output is correct or not. So after then we'll discuss this question. Don't worry. Okay. So meanwhile I'll check if people try the next question. Okay. I'll give me 1 minute. I'll check that question properly. Okay. So in the meantime, you try this second question. Yeah, I'll check that question. You people try this question. Okay. So everyone try this question. Okay. So 1 minute. Take a screenshot, everyone. So take a screenshot and try to read. Meanwhile, I'll try to write a code for the first program. Okay. So take a screenshot, everyone. Screenshot of this question and try to solve it. Give me 2 minutes. I'll check the previous question. Yes. Did you take screenshot? Yes. Yeah. Okay. So try to solve this question. Give me 2 minutes. I'll check the previous question whether the question is right or wrong. Okay. So if the question is right, we'll try to get the logic. If the question is wrong, we'll see. Okay. 1 minute. Yes, I'm there. Okay. So you people uh, try to check.